Hey guys, welcome to my channel and I'm back again with another really interesting coding interview question video. This time guys, we are going to solve question number 645, set mismatch. And as you can see on my screen, we are going to have another companies section because we have LeetCode Premium. So you can see that this question has been asked in Microsoft and Amazon, Google, Meta, Apple, Bloomberg and Adobe as well in the last 6 months. So definitely a quite recent question. Now let's get started with the problem statement. So basically guys, the problem statement states that we have a set of integers s which originally contains all the numbers from 1 to n. Unfortunately, there has been some error in which one of the number has gotten duplicated and one number is actually missing from the set. So there is one repetition and one loss or one missing number. Now we are given that integer array nums which represents the status of this set after the error. What we have to do is find out the number which occurs twice and the number which is missing, and we have to return them in the form of an array. So you can see that this is the example where we have got numbers from 1 to 4. So 1, 2, 3, 4 should originally be the set, but we have got 1, 2 to 4 where 2 is repeated twice. So the output is you have to give the number that has been duplicated, which is 2, and the number which is missing, which in this case is 3. So you can see that this is my output. Now let's see another example. You can see that these are numbers 1, 1. So we basically should have gotten a set of 1, 2, but we have got one duplicated. So the first number that we are going to output is going to be our duplicate number, that is 1. And the second number in that array is going to be our missing number, which is 2. So that is the example. Let's look at some constraints. That the length of the nums go from 2 to 10 to the power 4. It's going to be a huge array, and the value of the array value is going to go from 1 to 10 to the power 4. So everything is going to be a positive integer. Okay. So now that we know about the problem statement guys, let's look into some solution approaches. So the first approach that we are not going to implement but we are just going to discuss is the brute force approach. Okay, so let's say brute force. Now what happens in this brute force approach guys, that what we are going to do is we are going to actually iterate in this numbers array twice. Okay, so we just create two loops. So loop 1 which go from 1 to n, that is the length of the array, and then another loop which go from the number, and again basically another loop which checks that number every ith number. So let's say if this is I, so another loop which will check again from 1 to n, and this is going to check if I is duplicated. Okay, and also it is going to check if I is missing. So you can see that with these two loops, finally you will find out your duplicated element and your missing element, and eventually you will get your output. Now if we talk about the time complexity of this particular solution, it is going to be order of n to the power 2. And why is that? Because we are going to run two loops and every loop will go from 1 to n. That means we are going to check the array twice in a nested loop. That is why this is a higher time complexity. So obviously we are not going to use this approach guys. We are going to use a different approach. So now we know that there is a matter of duplication here, which means we are dealing with the frequency. So as I told you in my previous videos, whenever you are dealing with the frequency of a number, or you want to count how many times a number appears in an array or a set, the best way to approach it is to use a map or a dictionary. So what you can do here, you can just create a map, and then what you can do is go on a loop from 1 to n, or basically iterate over all the numbers. Now what we are going to do is that for every possible number, so if this is the number, I am going to put inside this the count. Okay, so let's say the count of the number, so count of num, let's say. And then once this whole loop is over, then I can go through this map again. So now the next thing is going to be looping the map. Okay, map keys. And what I'm going to find out in this map key, if any of the number value is actually greater than 1, that means it is duplicated. So obviously it is going to be the duplicated number. Okay, and the same thing with these loop statements. Actually you can loop from 1 to n. So loop from 1 to n, and if you find out that number, or if this is I, then you can use I. So if you find that ith number in the map and the value of that ith number is greater than 1, that means that ith number has been duplicated. That means you put it in the duplicated element. And if the I is not present in map, so if I is not in map, it means that this is the missing element. Okay, so with this approach you are able to implement this with only a time complexity of order of n. Why? Because you can clearly see that we are looping through this particular approach only once. We are only, actually not once, twice, but this is not a nested loop, right? So the first loop goes from 1 to n where we construct our map. The second loop also goes from 1 to n, but here we are just finding if our map is having a duplicate element or if a certain key is not even present in map. So if this loop takes order of n, this loop takes order of n, then definitely the total complexity is going to be order of 2n, which is still linear, and it is still better than the brute force approach, which was giving us order of n square. Okay, so this is another approach that we can use. But again, the thing with this approach is that although the time complexity is order of 2n, if you talk about the space complexity, this is going to be order of n. Because unlike the brute force approach where the space complexity was constant, we were not using any extra data structure. In this approach we are using a map, right? So obviously the space complexity is going to be order of n because we are storing all the n elements in another data structure. Okay, but time wise this still definitely does better. So this is one approach that we can use, and we are going to use now the we are going to discuss the most optimized approach where we use no space and we also have a linear time complexity. But first let's implement this particular approach. Okay, so let me just show you the code for this particular approach. Okay, so let's paste that code here and let me just go through the code with you guys. So first thing we are going to do is we are creating a map. Then we are going to create a result array, because you can see that our output is an array where the first element is duplicate and the second is the missing. Then we create two variables. One is going to signify the duplicate variable, which is dupe, and second is going to signify the missing variable, which is called as missing. Now, as I told you, first thing we are going to do is we are going to iterate through this nums array. We are going to check if this number is present in the map or not. If this is present in the map, we just simply increase its frequency by 1. If this is not present in the map, we just set the map frequency to 1. Okay. Now, we go into a range. So we actually iterate the numbers from 1 to n. So you can see that in Python, you have to say 1 comma length of nums plus 1, because the last number is not is actually excluded from the iteration. So this is a way that you can iterate from one index instead of 0 index. We range from 1 to the length of the array plus 1. Now we simply check if that number is present in the map or not. So if that number is not in the array, so if this if doesn't go through, then we go here, right? Then missing value becomes I. If that number is in the array, then we just simply check if the count of that number is equals to 0 or not. That means if the frequency is equals to 0, then we can set the duplicate value to I. And finally, we return the array with the duplicate value and the missing value. Now, another thing that you can do here, guys, is that in the first loop itself, if we find out that the number is present in the map, here only we can actually set this duplicate value to I. And actually, so I can just show it to you. Here only we can actually set this duplicate value to num. Okay, and in the second loop we can just simply care about processing the missing value. Okay, and both the solutions are gonna work. Now let me just run this code with you and show you that it gets submitted and it clears all the test cases. So there you go. So this is one approach. So now we have discussed two approaches, brute force approach and the array approach with an extra space. Okay. Now we can use another approach. Now in the second approach, guys, what we are going to do is we are going to again loop over our elements. Okay. So what we are going to do, we are going to loop over our nums array, which is nums array. So num in nums. Okay. And what we are going to do is we are going to check if that number, because we know that all the numbers are in the array are from 1 to n, right? So if 2 is present in the array, definitely the array size is 2 or more than 2, right? So for every number in the array, what we are going to do, we are going to take the number and we are going to set the value at that index to negative. So just simply what we are going to do is we are going to take that number and inside the nums array, wherever that number index is present, we are just going to set it as negative. Okay, we will make this negative value. Okay. And what we are going to check when we are looping the array, that if that number index, so let's see if that number index, if this is already less than 0, so that means that you have already flipped that number index to -1 and now you are encountering that index again. So if that index value is already negative, then it means that you have found your duplicate element, right? So your duplicate element is going to be num, and else you are going to do the flip, right? So with this first loop, you have already found your duplicate element without using any extra space. And now what we are going to do is we are going to run another loop where we are just going to loop from 1 to n, right? So now we will loop from 1 to n. And we are just going to check inside the numbers array. So if numbers array and at that index I, if this is greater than 0, that means that was the one index which never occurred in the nums array, right? So that index never came in the index array, and that means that index value will never be flipped. It will always be negative. So that means finally your missing value is going to be I, and that is how you return your output. Okay, you get both your missing value and your duplicate value. So what we are going to do is simply, because we know that array has absolute elements from 1 to n, we go through each and every number, we take its index, or actually we should do it num -1 because the index starts from 0. We take the number, we take its index and we flip it to -1. Here also should be my -1, right? And we find out if that index is already flipped, that means it came again in the array, it was duplicate. And finally we will loop through all the 1 to n elements and we will see if that number, or again in that case we should do 0 to n -1, right? And you will see if that index is actually flipped or not. If this is actually flipped, then we are going to just make the missing value I plus 1 because the index starts from 0 in the array, but in the actual scenario it actually starts from 1. Okay. And by this approach, guys, you can see without using any extra array, we have actually solved this problem with only 2 direct loops, and it makes our time complexity order of 2n or order of linear time complexity, as you can see. Okay. So this is the most optimized approach, guys. Now let's just look into the code for this, and I'm going to copy paste that code right now. Let's go through the code. So as I told you, the first thing we are doing is we are initializing our duplicate and missing value. You can initialize it to -1 or 0 because you can see that they are all positive integers, and also they start from 1. So you can initialize it to anything. When we go again, we iterate through the whole nums array and we check if the absolute value of the num, because we know that we have already flipped the element, right? So we need to make sure that this is the absolute value of the num, -1 because we know that the array index starts from 0. If the index value at this particular position is already flipped, that means it's already negative, then we know we have found our num's value. So we say do becomes equals to absolute or num. Otherwise, we flip the value. So we take the absolute value of the num minus 1. This becomes my proper index. And then I just make it the value multiplied by minus 1. And finally, in the other loop, we are just iterating from I until the whole range of num, which is from 0 to n. We check if the ith value of the num is actually positive. That means this index never came in this list and it was never flipped. That means my missing value is equals to that index plus 1, because again array index starts from 0, but in this thing we are going from 1 to n, right? Finally, we return the duplicate and the missing value in the array. Okay, and if you talk about this time complexity, it is going to be order of n, which is linear time complexity. And if we are talking about the space complexity, it is going to be order of 1, because we did not use any extra space for solving this problem. Okay, so these are the approaches, guys, that I have used to resolve this issue, resolve this problem. I hope you guys like these approaches and I hope you learned something from it. If you did like this video, guys, then please do not forget to like this video and share this video with your friends. If you have any questions, comments, suggestions, feedback for me, please do write down in the comment section below. I would be really happy to address them. And in the end, guys, if you have not yet subscribed to my channel, please do subscribe and hit the bell icon for future notifications of more such programming and coding related videos. I'll see you guys in the next video, guys. Until then, take care and bye bye.